Hello children, welcome to digital classes. Today we are going to discuss 9th class topic heat. In this topic we are going to study heat, temperature, their units and how the relation is there in between them. We will learn that hotness and coldness are relative terms. We are going to understand the concepts of thermal equilibrium by doing activities and how the bodies attains the thermal equilibrium. Is thermal equilibrium happens in nature every time? We will learn how to convert the temperature units from degree Celsius to Kelvin scale or vice versa. We are going to learn that how the motion of the particles depends on temperature by doing activities. My dear students, let us observe daily life situation, that is, have you ever suffered from fever? Whenever you are suffered from fever, what do? Yes, generally we visit the doctor. Doctor will measure the temperature of our body. How he measure the temperature? Which instrument will use the doctor? Yes, thermometer. While using thermometer to measure body temperature, what is happening? Okay, we will know the reading in thermometer increases. How long is it increases? When does it reaches to a particular point? All these answers we are going to discuss by doing activities. Heat and temperature. Dear children, look at this picture. What is it? It is a bench made up of iron frame. If we touch the iron frame and wooden plank, how do we feel? We feel either cold or hot. Sometimes cold, sometimes hot. Which is more cooler? Why? Observe this video. Hey guys, look at this video. What are they doing? They are sitting around a campfire. Did you observe anywhere? Yes, such type of cases we will observe in villages. Generally in winter season, people sitting around a campfire to relieve themselves from cold. By sitting around campfire, what they get? They get heat or heat energy. Here heat is supplied to human beings from campfire. Why they are sitting at campfire? What they get from campfire? Children, look at this video. A river is flowing here. If you keep your hand in the flowing river, sometimes you feel hot, sometimes you may feel cold. When you feel cold, when you feel hot, in summer at noon, if you keep your hand in river, you feel cold. In winter, early in the morning, if you keep your hand in river, you feel hot. By keeping your hand, how do you feel? Observe this picture. In general, we can lit the candle if there is no current in the night. We can observe feeling of hotness by taking our finger near to a candle. From these observations, if heat transfer from our body to surroundings, we feel coldness. If heat transfer from surroundings to our body, we feel hotness. Hotness or coldness are relative terms. In case of iron frame, by touching it, we feel coldness. It means heat is transferred from our body to iron frame. In case of candle, we feel hotness. It means heat is transferred from candle to our body. At campfire, we relieve from cold. It means that heat is transferred to our body from surroundings. In case of river, what was happening? Guess it. The degree of hotness or coldness is called temperature. Temperature gives the thermal state of the body. The SI unit is Kelvin and other unit is degree Celsius. Temperature tells how much body is hot and how much body is cold. Temperature is measured with thermometer. Thermometers are two types, clinical thermometer and other one laboratory thermometer. Thermometer was invented by Celsius. Now we go for thermal equilibrium or thermal stability. Two metal boxes are there at different temperatures. One is at 60 degrees centigrade, other one is at 40 degrees centigrade. 60 degrees centigrade body is nothing but hot body and other one is 40 degrees centigrade is the cold body. Now connect these two bodies with metal strip. Heat will transfer from hot body to cold body. But how long? Yes, it happens only up to the temperature of both bodies becomes equal. We call this situation as thermal equilibrium. After attaining the thermal equilibrium, the body neither receives nor gives out heat energy. For example, the objects in the room are thermal equilibrium with air in the room. After attaining thermal equilibrium, there is no transfer of heat from one body to other body. It means bodies neither receives heat nor gives out heat. It means that both bodies attains the thermal equilibrium. Let us now understand the thermal equilibrium by one activity. Attaining the thermal equilibrium of thermometer when it is placed in cold water and hot water. Here materials required: 2 beakers, 2 thermometers, hot water and cold water. Let us observe when we keep the thermometer in cold water. Pour the cold water in a beaker. Pour the cold water in a beaker. Place the laboratory thermometer in cold water. Put the laboratory thermometer in a cold water and observe the reading. Slowly it is falling and reaches to a particular temperature. Now here 25 degrees centigrade. After that reading in thermometer, the reading does not fall. It means that there is a thermal equilibrium takes place in between the cold water and thermometer. Here heat is transferred from cold water to mercury, that is thermometer. After attaining the thermal equilibrium, there is no transfer of heat from water to thermometer or vice versa. Now we can say that thermometer and cold water are said to be thermal equilibrium. Let us observe when we keep the thermometer in hot water. Take hot water in a beaker and place the laboratory thermometer in hot water and observe the reading. It is rising in thermometer and reaches to a particular temperature, here 67 degrees centigrade. After reaching this temperature in thermometer, the reading does not rise. It means there is a thermal equilibrium takes place in between hot water and thermometer. Here heat is transferred from hot water to mercury, that is thermometer. After attaining the thermal equilibrium, there is no transfer of heat from hot water to thermometer or vice versa. Now we can say that thermometer and hot water are said to be thermal equilibrium. Heat energy or heat. Heat is a form of energy. It always transfers from higher temperature place to lower temperature place. The SI unit of heat is joule, CGS unit is calorie. Calorie, the amount of heat required to rise the temperature of 1 gram of water by 1 degree centigrade. Calorie is equal to 4.186 joule or 4.2 joule. Temperature can be defined as the degree of hotness or coldness is called temperature. The SI unit is Kelvin and other unit is degree Celsius. Temperature gives the thermal state of the body. Relation between degree Celsius and Kelvin scale. Temperature in Kelvin scale is equal to 273 plus temperature in degree Celsius, that is capital T is equal to 273 plus small t, where small t is the temperature in degree Celsius. Temperature measured in Kelvin scale is called absolute temperature. Look at this picture. Here 3 metal boxes A, B and C are there. A and C are connected with metal strip. Similarly, B and C are also connected with metal strip. After some time, A and C attains the same temperature because heat is transferred between them. Similarly, B and C also attains the same temperature. We can say that now A, B and C are all at same temperature. It means that A, B and C are all thermal equilibrium. We can conclude that if two bodies are individually thermal equilibrium with third body, then two bodies are also thermal equilibrium with each other. This is called the zeroth law of thermodynamics. This zeroth law of thermodynamics leads to concept of temperature. So, zeroth law of thermodynamics can be stated like this. Out of three bodies A, B and C, if two bodies A and B are separately thermal equilibrium with body C, then A and B themselves are also thermal equilibrium with each other. Now, activity 2. So, this activity tells the relation between kinetic energy and temperature. Here, the materials required: 2 beakers, 2 food color refills, clips, pins, hot water and cold water. Now, food color refill is placed in cold water with the help of clip. Similarly, now food color refill is placed in hot water with the help of clip or stand. Observe the motion of the particles in cold water. Food color refill is placed in cold water with the help of the clips or stand. Now make a hole to the refill with the help of pin. Observe the motion of the particles in cold water. Children, what do you observe? The motion of particle is very slow. The food color particles are moving in cold water are very slowly. Here, temperature of cold water is less, therefore, motion of the particles is also slow. Observe the motion of the particles in hot water. Food color refill is placed in hot water with the help of the clips or stand. Now make a hole to the refill with the help of pin. Observe the motion of the particles in hot water. What do you observe here? Is there any difference before activity? The motion of the particle is here very fast. The temperature of hot water is high, therefore motion of the particles is also fast. The food particles are moving very fastly in hot water as compared to cold water. Observe the another activity for the motion of the particles in hot water. This is the another activity for to observe the motion of the particles in hot water. The materials required here: 2 glasses, food color, hot water, cold water. First take hot steamer with water, plug in the socket, we will get hot water and pour the hot water in a glass up to the brim. Pour the hot water in a glass and add food color to it. Observe the motion of the particles. Add the food color to hot water. Yes, motion of the particles is very fast. Now pour the cold water in another glass, add food color to it. Perform this experiment in your class with the help of your teacher and observe the motion of the particles. So you noticed that particle motion is fast in hot water and particle motion is slow in cold water. Since the temperature of cold water is less, particle motion is less. If the temperature of hot water is more, particles motion is also more. Therefore, motion of particles is more. It means that its kinetic energy is more. Relation between kinetic energy and temperature. The average kinetic energy of the molecules is directly proportional to the absolute temperature, Ke proportional to capital T, where capital T is the absolute temperature. Till now we discussed the heat, temperature and their units, and thermal equilibrium, hotness and coldness are relative terms, and also relation between kinetic energy and temperature, calorie, joule, etc. Think and discuss. Convert the room temperature 300 degree Kelvin to degrees Celsius. Convert the human body normal temperature, that is 36.9 degree centigrade, to Kelvin scale. Collect the information regarding temperatures noted at various places in India and also tabulated it. Why ice cream melts when it keeps outside? And also children, discuss with your friends where thermal equilibrium takes place in daily life. And so far you have seen the digital videos about the heat, temperature and thermal equilibrium, and also we performed some activities regarding thermal equilibrium, like how the thermal equilibrium occurred in the thermometer, when it kept in hot water and cold water. I think you might have understood the equilibrium, and also you have learned how to convert the temperature units from degree Celsius to Kelvin scale. How the motion of the particles depends on temperature, that is, motion of the particles directly proportional to temperature. So, therefore, we can say that kinetic energy proportional to absolute temperature. Now, think and discuss with your friends. We always supposed to do blow air while drinking hot tea or hot coffee. Why? While bathing, we always add normal water to hot water. Why? Collect the temperatures of various places in our country and make a table. Children, in coming lesson you will learn specific heat and its units, and also applications of specific heat and principle of method mixtures. Until then, bye.